Okay, I'm doing this in reference to review question number 15, and still having trouble understanding it a bit myself, but I guess this is the best way for me to explain it. So the question reads, how could you detect the Earth's precession by examining star charts from ancient Egypt? And it takes a little bit to understand precession itself, so this is how I kind of understand it. If this is the Earth, alright, um, I know it's hard once you're on a scale of not the well, yeah, the universe in outer space. Once you're in the scale of outer space, there really is no up and down. But in reference to this orange bar that you see here is the rotation of the Earth, and this blue vertical bar, for lack of a better word, is where the orange bar should be. It's where it should be rotating, because in terms of the elliptical path, it follows around the sun. It goes in a big circle that would like match the blue bar. Let's get a top view, so I guess I could show you in a sense what I mean. So we could see the blue right there on top. If we had some type of ellipsis, let's say something like that. Alright, so let me I won't get through this quickly, just to get back to the real important part that's about the elliptic. And I guess even though I'm not really drawing anything to scale, but the sun would be somewhere in the middle here. You know, I really don't care about scale. This blue bar rotates along that blue circle. Now imagine the orange bar. If it rotated around the orange bar, I can actually simulate that also. I just have to draw it on top of that orange bar. Okay, so if it were following the orange bar, it would rather follow this circle here. Okay, but it's not. It ends up following this blue bar in a sense. I hope you understand what I'm saying, and let's get on to the question. So, again, detecting Earth's precession, and what precession is basically how this orange bar goes around and around this blue bar in a sense. It keeps changing the tilt. Here, let me show you again. If I were to go like this, let's see. See, that's precession in a sense. I drew this 3D model. It's not the best, and the blue bar I'm seeing right now is not exactly in the center. But it's the precession is that orange bar going around the blue bar, basically, of how it rotates. So, how are we able to detect this based on charts from ancient Egypt? Well, let's use our star over here. Alright, and let's see, what's facing that star? No landmass. So let me rotate the Earth here. Oh, I have to click everything. Nope. That. So I want to try to get Florida facing. I should get this thing in the middle. There we go. Alright, so rotating Earth. Let's see. Almost got Florida facing it. I think that's about good, right? So now Florida is facing that star. Good. Alright, and you notice that the orange bar didn't move. It stayed in place. The Earth just kind of rotated along that axis. So if I were to draw this pencil, grab that line, and take it to the star, it has a certain angle, if you will. So you can see that there. Now what happens when we go ahead and change the precession? And let's go ahead and do that. Let's see. So the precession changes. You'll see that this angle changed over here. And remember how the Earth is turning. Do not forget that. It's super important that daily the Earth turns like this along the orange bar. It rotates like that. It doesn't rotate commonly around the blue bar, it rotates around the orange bar. Alright, so with that in mind, the position now from Florida is different. You can see that. So if I get my pencil, grab it from Florida now, and take it back to the star, there's a difference. And it is this difference that shows us how we can detect it. If we look at the charts and of the angle of the position of the star compared to ancient Egypt or something, we'll see a difference in the angle, and that's how we know that there's precession. Okay, hope you got my explanation. Thank you. Okay, how do I stop recording? There we go.